This slide set is about the dynamic host configuration protocol. As a computer user, you can configure the network interface card settings manually. For instance, you can open the adapter settings in Microsoft Windows and then open the IPv4 or IPv6 configuration menu. This allows you to enter the IP address, network mask, default router, and DNS servers manually. If it is necessary to configure this only once, then this is not an issue. However, if you have, for instance, a mobile device that you want to use in different networks, for example at home and at work, then this becomes relatively inconvenient to reconfigure it every day. Also, in networks of a certain size, it is not easy for administrators to keep an overview of the network configuration on each computer if it is entered manually. A better way is to use the protocol DHCP. The dynamic host configuration protocol allows for an automated assignment of IPv4 addresses. The address assignments are valid for a certain time, but they can be renewed. The administrator specifies a so-called address pool. This is a set of addresses which are available for temporary assignment. Permanent assignments are also possible, in particular for servers. This is interesting so that they can be reached all the time using a well-known IP address. Such a permanent assignment is realized based on identifying the server via its MAC address. In addition to the IPv4 address, it is usual to provide additional configuration data such as network mask, default router, and DNS servers. In this slide, we see a simple example where an address pool is available. A mobile device that joins the network then gets one of the IP addresses from the pool. Now we take a look at the protocol data units. The first data unit is sent by the client and is called DHCP Discover. By using this data unit, the client searches for a DHCP server. Please note that the client has no knowledge about the network at all yet. Therefore, it uses 255.255.255.255 as destination address. That is, it sets all bits of the destination address to ones. This is necessary because it has no idea about the network mask. Its own address is set to 0.0.0.0. In addition, we can see that port numbers 67 and 68 are the well-known ports of DHCP. If there is a DHCP server, then it replies with the DHCP offer. This means the server offers an IP address from the pool to the client. In the next step, the client does not use the IP address immediately, but requests that it can use the address in the future. Finally, the DHCP server acknowledges that the client can use the offered IP address. Since the assignment in this example is valid for 1 hour, it has to be renewed later, which is indicated at the bottom. In the data units, transaction numbers are used to identify the relation of requests and responses. Maybe you are wondering whether it is possible to make the communication flow easier so that just a request and a response would be sufficient. However, it is crucial that DHCP works in a reliable manner. Without getting an IP address, end systems are not able to communicate. Therefore, you may configure 2 DHCP servers so that clients get 2 replies when they ask for an IP address. They then just select one of the offered IP addresses.